Everything around us, from the smallest grain of sand to the largest stars, is made of matter. But what is matter made of? The answer lies in tiny particles called atoms. Atoms are the fundamental building blocks of all matter in the universe. They are incredibly small. Millions of atoms could fit across the width of a human hair. Understanding atoms is key to understanding the universe itself. By studying these tiny particles, we unlock secrets about the fundamental forces that govern the cosmos. At the heart of every atom lies the nucleus, a dense region containing two types of particles, protons and neutrons. Protons carry a positive electrical charge. This positive charge is what defines an element's atomic number and its place on the periodic table. Neutrons, on the other hand, carry no charge, making them electrically neutral. Together, protons and neutrons give an atom its mass. Whizzing around the nucleus are even tinier particles called electrons. Electrons carry a negative charge. They are attracted to the positive charge of the protons in the nucleus. This attraction is what keeps electrons in orbit around the nucleus. The arrangement of these electrons determines an atom's chemical properties, such as how it bonds with other atoms. Protons and neutrons are not the smallest particles in the atom. They are made up of even tinier particles called quarks. Quarks are held together by another type of particle called gluons. Gluons act like a strong glue that binds quarks together. There are several types of quarks, each with unique properties. Understanding quarks and gluons is essential for understanding the strong nuclear force, one of the four fundamental forces of nature. Section 5. Beyond the atom, leptons and neutrinos. Electrons belong to a family of particles called leptons. Leptons are fundamental particles, meaning they are not made up of smaller components. Another important type of lepton is the neutrino. Neutrinos are nearly massless particles that rarely interact with other matter. They are produced in nuclear reactions, such as those that occur in the sun. Trillions of neutrinos pass through our bodies every second without us even noticing. Section 6. Antimatter, the universe's mirror image. For every particle, there exists an antiparticle with the same mass, but opposite charge. For example, the antiparticle of the electron is the positron. When a particle and its antiparticle meet, they annihilate each other, releasing a burst of energy. The concept of antimatter has fascinated scientists for decades and has even been explored in science fiction. Section 7. Exotic particles, mesons and baryons. Besides protons and neutrons, other particles are made up of quarks. Mesons are particles made up of a quark and an antiquark. Baryons, on the other hand, are made up of 3 quarks. Protons and neutrons are examples of baryons. These exotic particles play important roles in high-energy physics and help us understand the fundamental forces of nature. Section 8. Forces of nature. The 4 fundamental interactions. The behavior of particles and the interactions between them are governed by 4 fundamental forces: the strong force, the weak force, the electromagnetic force, and the gravitational force. The strong force, mediated by gluons, holds the nucleus together. The weak force, mediated by W and Z bosons, is responsible for radioactive decay. The electromagnetic force, mediated by photons, governs interactions between charged particles. Finally, the gravitational force, the weakest of the 4, acts between objects with mass. Section 9. Unraveling mysteries, the quest continues. The study of particle physics is an ongoing journey of discovery. Scientists continue to probe the depths of the atom, searching for new particles and forces. Large particle accelerators, like the Large Hadron Collider, smash particles together at incredibly high speeds, recreating the conditions of the early universe. These experiments help us unlock the secrets of the universe and answer fundamental questions about the nature of matter and energy. Learn more at adaptiveenergysystems.com.